Hello and welcome to the Computer Vision Festival, hosted by the AI Accelerator Institute, a global community of over 400,000 AI leaders and practitioners, all striving towards one shared goal: inspiring the next generation of machine intelligence. With expert presentations on the festival agenda covering everything from space exploration on Mars to self-supervised learning, you're in for a treat. If you have any questions for our speakers or want to connect with them further, then ask away in the comment sections of the video and hear them answered at the end of each session in our live Q&As. If throughout the day you're loving the content, then be sure to check out the AI membership plans, where you can get access to exclusive content in the form of interviews, reports and articles. Access all areas passes to all past and future events. You can also join our Slack community, which is home to more than 2,500 fellow AI, machine learning and computer vision professionals, and is full of dynamic conversations and contributions. So if you're not already a member, come and join us today. Sign up using the link on the AI Accelerator Institute website. I want to say a massive thank you to all of our sponsors and partners for helping us to bring the festival to your screens today. Our amazing speakers for contributing some awesome content, and to you, our attendees, for joining us today. That's it from us, so go ahead, sit back, relax, and enjoy the festival. Okay then, so we will just give it a couple of seconds for everyone to enter the room. Looks like everyone is filtering through now. Okay, great. Let's kick this off, JT. So welcome everybody back to the next session of the Computer Vision Festival. I'd like to introduce you to JT. He's the Senior Director of AI and Machine Learning Engineering at Change Healthcare. And he is here today to speak to you on the use of OCR at scale in processing medical claims. And on that note, JT, I'll leave it over to you.
Yeah, thank you. Thank you, Jordan. Nice meeting you all. Let me give a quick introduction about myself. I'm JT. I'm Senior Director of AI and Machine Learning Engineering at Change Healthcare. So I've been with Change for a little over 2 years, and I've been working on AI for past around 6-7 years. Main focus is on developing a platform at scale, as well as sort of applied AI. So I worked on different areas like storage forecasting, predictive AI, as well as in this case, I'm doing a lot of NLP and OCR and computer vision as well. So in the context of different domains like industrial appliance at GE, and at Veritas, I was heading the storage units as in the storage business at Change. I'm doing mainly the healthcare data as well. So let me give a quick overview of what Change is. So Change is the largest healthcare network. So we sit in between the providers for the hospitals and other clinics, and the payers. We were the insurance companies and other government entities who pay for the service the patient is taken from the providers, and we process their claims. So that's sort of the big business we do. In addition, we also have a number of software and analytics solutions for the hospitals and the providers as well, payers as well. And so AI plays a major role in the sense, we use AI. We're able to use AI mainly because we transact with a lot of volumes of medical data in terms of claims data, which is 837, as well as patient records, which goes through our network. We do have access to almost 1/3 of the entire US patient records as well. So then it opens up a lot of opportunity for us to use the data to process the claims, which is a pretty very long process. It may take up to 120 days to process a claim and pay the provider. So our idea is to use AI to sort of optimize these workflows, so you can get it get it paid within 24 hours. So those are some of the initiatives I'm working on. The other areas I'm working on is a risk assessment of the patient. So essentially we do understand, we look at the patient history and say, hey, this person is, we provide a score for the patient, risk assessment score of the patient, so that the insurance, the payers can look at that and provide a quote for the providers. So those are some of the interesting areas I work on as well. So the way we have been approaching AI is almost like in changes. We want to create a scenario like Facebook. For example, if you look at Facebook or YouTube, it almost feels like the system knows about you because they have access to all sort of data. For example, your behavior in the past, as well as what you did in the browser cookies, or what are the searches you did. The user did, as well as the telephony network, like the location of the user as well. So they have access to all this data, and then they curate the content based on the user's interest. So we want to bring the same experience to the healthcare applications as well. So we want to process all the data in our system, like eligibility data, claims data, and then almost when the patient comes in, we'll know, hey, these claims belong to this patient. This patient has got this issue. Create this knowledge graph and tie up all these things together. So that's the work I'm doing with this with the change as well. And we're taking a platform-centric, a service-based approach. Essentially every AI component we built as a service, microservice, and OCR is one of those services we have built. And then the idea is to wire up all these services together and build an AI application in a seamless fashion. So in this case, like you can see, using a command line, I can create an OCR service, an instance of OCR service, and then I can point that to a S3 data store where our patient records are there, and then we OCR the records in one click of button. So that's the approach. We're taking a platform-centric approach or a service-based approach to AI as well. So we have built a number of pluggable services, and using that, you basically create a composite service, and then you eventually use that to create a machine learning application as well. So you can see here we have a model training service, we have workflow service, we have REST API service, and then we bring everything together and create a composite service. For example, I can create a data management service using 3 pieces of the puzzle, data processing, storage, and workflow. I can create a data management or a feature store in this case. Or I can say, I want to build an OCR pipeline for a certain type of chart. I can then bring it together, the workflow and the queue management and the OCR service. And in this case, it becomes an OCR, feature for that application. Then you combine all these things to build an ML application. For example, you plug in the training, your inference, your scoring together, and the outcomes get stored as well. So that's sort of the approach we are taking. And OCR is one of those services we have built, which I want to dive into that, which is a very interesting service we have built as well. So as you probably know, I have talked about different type of data we're dealing with. One is the claims data. The claims could be in electronic format, 837 or 835 format, or it could be somebody faxing the claims. They can fax it to us, or a lot of, or even mail it to us, for the claims to be processed. A lot of the hospitals, they still mail us those claims. Then we take it and OCR that and convert that into an electronic format as well. So OCR is used in that circumstances. In addition, we do access to a lot of patient records. For example, we do patient records and patient charts and other things in large PDFs. Then we had to OCR those as well. So the OCR has to scale up and down. So the way we have to think of OCR services, it has to be used in different use cases. So I don't want to reinvent the wheel again and again. So that's why we built a service, and the service also have to scale up and down. If I throw 10,000 pages in a chart, it could be like 10,000 pages, or it could be a small chunk of charts, or a claim could be like 5 pages as well. So I need to scale up and down as well and process these large, charts as well. And it also had to be very simple. It has to be in one command line. I wanted to start processing, millions of OCRs as well. And the output should be stored in a nice format as well. So those are some of the requirements we had. So in this case, we have created an OCR service. All you do is just create a simple command line. You just point the input and say, hey, I want to put all the output of the OCR here, and then I just execute. In one command line, so that's the beauty of the work we have done. It's highly scalable, as well as it's configurable as well to adapt to different projects. So let's look at what is the guts of this OCR. So what are the options we have? So I can use Azure, or I can use Amazon TextRact or Google OCR. So those are 3 top contender we had. In fact, when we started off, it was more like primarily Google OCR was the leading engine at that time. So we did look at the options and how do we evaluate a system like this. So we came up with a set of criteria. So obviously the performance is one of the high importance. Performance is of great importance, like the accuracy of accuracy of the output. If it is it should be similar. It should be very exactly like ground truth. That's the ideal case. Or it can also be similar. For example, there could be some variation. Maybe there is a drop character. As long as it's similar, so we use those 2 metrics in terms of accuracy and similarity, as well as those are the 2 main metrics we used in terms of performance. In addition, we looked at cost. How is the cost factor looking like? Is it can I OCR millions of documents? That's the case, and not burn my budget. How effective it is. So the other one is how easy it is to integrate. Can I just call API, or do I need to install things in our systems, and how it scales for the load you're going to throw at it and the throughput we want for the output of our workflow as well. So we looked at those things as well. In addition, we looked at the certification because we are dealing with healthcare data. So we want that to be highly secure and HIPAA certified and BAA certification as well. So those are simple criteria we stood up, and then we compared against this top contender Google Vision. And then you can see the cost is pretty low, pretty similar for 1,000 pages. It's 150 per 1,000 pages, as you can see. The certification is at one point TestRact had to be certified, but I think eventually at this point all the 3 are certified. In terms of ease of use, ease of use is also pretty. It's all API based. You can just use it as long as your company has access to those cloud services. You can pretty much use it out of the box very easily. So I think you had to think of some sort of data strategy as well. So where is your primary data lake? In our case, our primary data lake was AWS. I was able to do a secure call out to Google and get the response back. And the accuracy and similarity, you can see the numbers. The Google Vision and Azure is on the top. So eventually, we went with Google Vision because it was one of those things that is already, it is the longest one that is available in production grade, as well as we had a prior relationship with Google, and it was easy, choice for us to go there. Although we used AWS as the primary data store, we still went with Google because of the performance and the certification they had at the time. So I just want to also dive a little bit deeper into the architecture. So we used, then we had to once you chose the OCR, So these OCRs can only scan like typically one page at a time. So in our case, we have, I mean, like I said, 10,000 pages or even more, 20,000 pages. How do you scale to that and like, make it like a coherent, 10,000 page document into one page? So we have to do some sort of work on that. Like, we have to scale that system. So we use, our primary, since our data is all in AWS, we use the AWS infrastructure to scale it. Like, we use ECS, which is Elastic Containers. So essentially what we did is we put the OCR runtime into a container and then sort of scaled it. And then we built a set of 3 containers. One is get the PDF, collects the PDF from the input, batches the PDF into 50 pages, and then converts the OCRs, the 50-page chunks into JSON. And we introduced a queue in between to do the asynchronous processes. So that's sort of the process. We built 3 containers and you orchestrated those containers as well using the SNS. So you can see the high-level architecture is the data comes to the S3 bucket, and then we have a compute cluster, and then it calls the OCR systems, and then the compute system basically splits the PDF into smaller chunks, and then calls the OCR, Google OCR in this case, and then put the output back, collects the output back into S3 as well. That's the sort of the high-level architecture. So going into the details of it, like you can see here, once the data comes into the bucket, we use the get API, get PDF container, and then bash it into 50 pages. And then we spin off of hundreds of thousands of containers, which basically does the OCR calling Google, and then it goes down to the S3, and then we, at the end of it, we know this particular set of PDFs have been processed, and that's sort of the way we do the OCR and scale it, scale as well. I mean, there are a bunch of challenges we had in terms of scaling the containers. Sometimes the containers will, time out, or if Google, has the ability to throttle it. So they basically do a lot of throttling. So we have to make sure our container is, it doesn't wait and sort of time out. So then we have to work with Google and sort of increase the quota for us. So that's one challenge we had. So that's the main challenge we had. And there's a limit on how many containers you can spin off in ECS as well. And there's a cost associated with this containers as well. So you have to balance those with the throughput you want to get it out of the system as well. So with this model, we're able to process almost hundreds of thousands of charts within an hour. So the OCR itself is time-consuming things because of various different steps, and the OCR itself may take some time, up to 1 minute as well. The response is not very instantaneous, so 30 seconds to 1 minute. So that's why we have to the time it took us was around an hour to process 100,000 charts as well. It also depends on the number of pages per chart. So roughly around that, we got that. So again, going into we made it extensible such that I can use different image conversion engine. We used, so we had to actually convert that into PDF into image. So we used PDF to image. So I can swap it into different ones. And I can use different OCR APIs. I can switch the containers between OCR or Azure, or even third-party library like Tesseract if you want. And we also converted the output into Parquet instead of JSON, so you can import that into Athena tables for further processing, or the downstream process can do that as well. So the one other interesting thing we did is we don't want to keep running all these ECS instances. So we basically have the automatic scaling. So it takes 5 minutes also to warm up. So these big containers. So we did ability to scale up or down as well. We added those abilities. So it's naturally depending on the throughput, it adds more ECS containers and it shuts down as well. Otherwise, the cost will be more expensive. So this is sort of the typical one example I had in action. Like, for example, the claims forms in this case comes to change, mostly using this case, like using FTP services and other things, like, and then we do have a model, and then like, and then we have the OCR, which goes through the OCR pipeline, and we have custom workflows. The user, does some activity on that, and then we process the claims. We're able to, like, sort of see a lot of reduction in the process claims because of this one example I have as well. 56% reduction in human processing needs, because the AI is able to, like, because of the introduction of OCR and AI model, we're able to, like, do uplift in this case. So I just gave an example of the type of model we have as well. I don't want to go into the detail in this particular session. So this is some of the examples of I think the claims forms are missing. Okay, yeah, this is some of the examples of the claims forms and IBIL type of processing we did. Yeah, thank you so much for attending the session, and more than happy to answer any Q&A as well.
Hey, JT.
Hi, Jonah.
Hi, great presentation.
Oh, thank you very much.
Thanks a bunch for putting that together. Yeah, so why don't we open up the floor for some Q&A? As usual, just post your questions in the public chat box, and we'll try and answer them now for you. So thanks, Shiva, for the first question. Why did you select Google OCR to work with rather than Azure?
Yeah, I think totally agree. That's a good question. We did, we did see good accuracy with Azure as well, but at that time we didn't have like cloud agreement with Azure. Since then, things have changed. Like, we were already had existing agreements with Google and AWS. So that's the main reason we went with Google OCR. And Google OCR has been there for quite a long time as well. They've gone through the certification and other things. And I think that is the main reason. The comparison was a little bit like almost like same. It's not like massive difference. So, I mean, those are some of the reasons we went with that. I mean, typically you don't, just because the performance is good, you don't jump to that. There are other dynamics in play in corporations like that.
Well, thanks, JT. Thanks for the question as well, Shiva. So 2 questions up next from Chalita. Question 1, are you using customized OCR? Question 2, I'll let you answer them both together. Question 2, do you use any deep learning models in conjunction with OCR? 4 questions actually, sorry. So what challenges do you face with so many document formats? Question 4, do you also process handwritten medical reports? If so, could you talk about it? There you go,
yeah,
Jake.
I can talk about. Let me address the first one. Are you using customized OCR? So we're not using any customization to the OCR. We just call the API. Mainly, we tweak the throughput. That's not any other hyperparameters. So pretty much we use it out of the box. I mean, these APIs are very simple to use. They don't provide any additional interesting like things you can configure. So we use that almost like out of the box as well. I mean, yeah, absolutely. We use deep learning model in conjunction with the OCR. So after the OCR output, I have many deep learning models. Like, we do deep learning model to extract entities. Like, so that's one of the reasons we do OCR is to extract the diseases of the patient or look at the claims data. Like, what are the data? I can use that to do prediction on, like, on the claims, whether the claims can be processed or not. So definitely we do that after that. So I have a chain of models. It's just not one model, many different models doing that. So There is not really many different format because we are using it in the raw format. Keep in mind, like all we are doing is we're OCRing different documents, and it gives you a big JSON with different coordinates of what is what is the output and this particular bounding boxes. So it basically says that the top right corner is my OCR name, then I had to use the model to extract those things. Like the patient name is probably in the top right corner. I can extract those or entities there. So we don't really care about the format of the documents, because that's where the model comes into play and extract those entities out of this large gigantic document. Obviously you have to go through a training session, so you need to train this document. So once you OCR it, we have a labeling tool, which I didn't go into this. So then we map those coordinates with the document and then use that as input to the model. Then I can extract it out. So we do like labeling and training, which I didn't go into that in this deck as well. Yeah, I mean, it's we do process handwriting medical records. Incidentally, it works out of the box. We don't need to do anything. Like you just put the handwriting, it actually transforms that into some bounding box with some text. I think it's pretty advanced, as I can say, as you can see. We don't need to do any special treatment for it. So these are all pretty raw PDFs converted into the images, and then just goes into the OCR. So yeah, it's fantastic. I mean, change in input. Okay, I think I addressed all the question there.
So next question. I have a question about template 2. How many different types of claims can it handle?
So I think for some reason the claims document, I don't know what happened to this. It disappeared. I think I can probably upload. We handle different types of claims document. I mean, like I said, like 837s, 837 itself. I mean, it's a generic format for claims, and then different types of claims. The content can go into that for sure. It is pretty straightforward, because all it does, the OCR engine does, is it takes a document and puts bounding boxes. We are not doing anything. OCR is not doing anything beyond that. Then it's up to us to do the processing. You have to then take it, train your model, and say, for example, let's take an example of iBill here. This is a bill here. So you can see here, the left side, it's a list of dates. You have to train your model. You have to label it saying this is a date, this is the header. I mean, in this case, we are using it in the raw format, which is the most flexible format. All you get is a bounding boxes. Then you have to have a labeling tool which maps that, and then use that for your model, which is a fantastic approach as well. Or you can use a more programmatic way. Like you can say this particular set of things is names, this particular type is you can do that as well. Most of these bills will be similar, very similar. So you can then create a small rule engine, which we have done as well, and then use those rules to process these charts as well. So we have done both of these things. We found modeling to be a little more flexible, because things change and modeling can adapt. So that's sort of
cool. Nice one. Thank you, JT. And then we jumped over Kartik's question there. Did you want to answer that? He's just asking how easy is it to change changing the input formats?
Yeah, absolutely. I think the input format is pretty easy to change. All I need to do is, like I said, let me go back to the slide deck a little bit, few more. I just want to show you. So here, all I'm saying is, here's my input in S3 bucket. I mean, I can just give a folder. That's it. And then I just invoke this service pretty fast. So I mean, it's as simple as that. It's a YAML file we have. So you put that in a YAML file, and it just processes it. So it's very easy to change different inputs, different formats. We support all those things because we leave all the heavy lifting to the post models and post the OCR processes.
Okay, got it. Thanks, JT. So where are we at? So from Sandeep, how do you verify the correctness of a process document?
Yeah, I think that's a great question. So essentially what we do is we take a ground truth. So someone has to manually do that work. I mean, like in the correctness of the process document. So I think this really, like, we did that for the first time. Like, that's the only time we did that, just to do comparison where we annotate, like, a document and created this ground truth. I mean, obviously, you need to have a ground truth for all this, like your models, and then that's where it happens. When you predict, like, it gives it some percentage, saying, like, the probability of this prediction is certain number. So then that's where you determine whether you like it or not. Like, so that's the process we have to follow. So you create this ground truth with for your model. I mean, it's like any other machine learning. You create your ground truth, which is like, somebody manually annotating and labeling it, and then you run your model and it spits out an output with certain percentage. Then you use that to calculate, like, hey, I mean, how correct it is and things like that. And then you use additional post-processing tricks, like, fuzzy matches and, like, Levenshtein distance to narrow that out. Like, so that's typically the way we do that. Everybody does that.
Nice. Thank you, JT. Really informative. So looks like we've got one last question here from Shiva. Do you use any denoising neural networks for scanned old documents? If no, what kind of approaches you have had?
Yeah, this is one thing I think in the use case. I just want to quickly go through that. Oh, okay, in the wrong direction. So the use case I showed, actually, we're doing that. I think before the OCR. So in this particular use case, before the OCR, what we are doing is we are pumping a model which does this denoising. Essentially, when they scan a skewed document, things like that, what we do is we use the CNN network, CNN model to process the image as it is, and then, like, sort of we align it. We actually extract the format out of this form and put it overlay into a new form, and then compose a new form and send it to the OCR. Because we have this in this particular equation, there's a legacy OCR sitting. We are not able to replace that OCR. So we did this denoising. I mean, exactly what you're asking. I mean, that's the opportunity there as well, especially when you have a brittle process. You cannot go and uproot it, because this was running for years and years and years. They had an old OCR, which is, I mean, doing the right thing, but, like, you cannot replace that OCR with the new one. So we have to do that with the denoising. So we did that trick there.
Nice. So yeah, really informative answers there, JT. It looks like we've come to the end. Unless anyone wants to pose one last question. If not, we can wrap it up there. But just as Kartik is saying, yeah, that was an amazing session. Seems like the audience loved it. It's been great working with you, JT. You're welcome back anytime. And yeah, carry on innovating. You're up to some awesome stuff.
Yeah, thank you, guys. Like, enjoyed talking to you. Great question. Good luck with all your things, OCR things.
Cool. All right, JT. Thank you very much. You take care.
Take care.
Thank you. And